Hello class, let's begin. Let's look at section 8.1. Inverse variation. Inverse variation. This is section 8.1. Okay, so in looking at inverse variation, we did something called direct variation a little while back, and I'm going to do some comparisons as we go along. So I'm going to make a little chart here, and this is going to say direct variation, and this is inverse variation. And let's do some comparisons. And maybe it's good to have this old direct variation stuff here to review. This is on your midterm exam as well, but it wasn't on your last test. So maybe, I guess, certainly we need a little review. So for direct variation, the equation was y equals kx. So equation. For inverse variation, it's going to be y equals k over x. Okay, so you can see in inverse variation, we're dividing instead of multiplying by the x. We have the k, and this is the test. So when it says, is this direct variation or inverse variation or whatever, we use the test to find k. So with direct variation, it's y over x. Okay, because if you solved this for k, you divide by x. If you solved this one for k, it'd be y times x. So if a problem or if a situation is direct variation, whenever you divide the numbers, you get the same result, which is k. For an inverse variation, if you multiply the numbers, you get the same result, which will give you k. Finally, what do I want to call this? I want to call this the if-then problems. Okay, so for example, the problem might say you have direct variation, and when x equals 3, y equals 4, then whatever. So the situation we used for direct variation was like a proportion. Okay, so it's going to kind of say, well, this is going to still be the same no matter what. So if y equals 4 and x equals 3, then when y equals 6, x equals whatever, and we'd solve that proportion. So if your if-then for inverse variation is going to be yx equals yx. Okay, that was a bunch of just boring equations and whatnot. So let's look at an example of a situation where we have inverse variation. This stuff happens all the time. So let's say you're going on a road trip with some friends. You're going on a road trip with some friends. And you split $100 worth of gas money. And you split $100 worth of gas money. Okay, well, so let's see what happens here. Let's see your friends. This will be your x variable. And your y is going to be how much each person pays. And let's pick some numbers that work pretty evenly. 2 friends is $50. Let me see, 4 friends is 25. 5 friends is 20. 10 friends is 10. And so I could keep going on, but that'll be enough to see what my curve looks like. Okay, so let me see. X goes from 0 to 10. I can just mark that off. The y-axis goes up to 50. So let's say, I think that'll be good. Okay, and let's see what this curve looks like. So 250, 250, 425, 425, 520. 10, 10. So this graph, let me put it in a different color here. It's going to look like this. It's like it's decreasing. And as I add more friends, I guess that not that many could fit in the car, but this will keep getting smaller and smaller and smaller. It never reaches 0, but it would just keep getting smaller and smaller and smaller. Never 0, negative, never negative. So always decreasing, but always also above the x-axis. That's kind of weird. It'll just always get smaller and never touch. And in theory, this line would go up and do the same thing. We could always get closer to the y-axis, but never touch. That doesn't make sense in the domain of my problem, right? The domain is the possible x values, and that's just whole numbers. I can only have a whole number of friends. And then the range is just whatever numbers come out of there. So it's kind of silly to think about having, what's happening with the graph going up here. In theory, we can do it. The math works out, but it doesn't work in the context of the problem. And I probably couldn't fit 10 friends in my car. That's silly. I'd need a big van. One last thing I want to note is just general equation setting up stuff. So a general equation setting up stuff. Oh, I can't believe myself sometimes. Okay? When you see the word varies, you're going to put equals k. So if there's a variable out here, y varies, you write y equals k. And then you're going to see some words. You're going to see some words like jointly, directly, and inversely. Okay? Well, you're going to set up let me set up a fraction here. So jointly and directly go in the numerator, whatever variables are after them. And inversely go in the denominator. So general equation setting up stuff. So you'll read through the problem. It'll say blah, 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 blah. When you see varies, you write equals k. That's important enough to section off. So some variable varies, and it'll say jointly or directly or inversely. Or it might just say one of those things. It might say all three or just a couple. Stuff when it says jointly and directly, put it in the numerator. Anything that says inversely, put it in the denominator. I guess if it doesn't have inversely, you just won't have a fraction. But IJS, it's got to be there. Okay, those are your notes. Yeah, left-hand side of your notes stuff. Do it.